In 2020, the world discovered the true meaning of dependency.
We are now importing 95% of our chips. We should have been the leaders, but we are the laggards.
Car plants in India didn't slow down because of lockdowns. They stopped because the chips stopped arriving. A global semiconductor shortage, affecting more than 169 industries, brought entire supply chains to a halt. For India, this wasn't just an inconvenience. It was a wake-up call. A nation of 1.4 billion realized that the future of its economy, defense, transportation, healthcare, and digital infrastructure was built on components it had no control over. Components manufactured thousands of kilometers away in Taiwan, South Korea, and China. And for the first time, India said, never again. Union Minister Ashwini Vaishnaw puts it bluntly. Semiconductors are a foundational industry. They power every modern device, from smartphones to satellites, from high-speed trains to medical imaging systems, from 5G equipment to defense missiles. Global semiconductor revenue crossed $500 billion in 2023, projected to hit $1 trillion by 2030. TSMC alone controls over 50% of global foundry capacity, and Taiwan as a whole commands nearly 60% of the world's advanced chip manufacturing. It's not an exaggeration. Chips are the new oil and the new sovereignty. In the 1960s, Fairchild Semiconductor, the company whose founders eventually started Intel, wanted to build in India. The offer was ignored. Taiwan accepted and built a $600+ billion semiconductor ecosystem. India set up the Semiconductor Laboratory in Mohali in 1984, but it remained stuck at 180 nanometer technology while the world marched ahead to 7, 5, and 3 nanometers. Meanwhile, India became the world's second largest mobile phone manufacturer, but still imports nearly 100% of its chips. Even today, electronics make up one of India's largest imports, rising from around 1 lakh crore rupees in 2011 to 6,20,000 crore rupees in 2023. But the deeper wound was this. India failed not once, but twice. In 2006-7 and again in 2015-16. Both attempts to build fabs crashed before breaking ground. The global industry concluded India couldn't execute. Large Indian conglomerates told the government openly, if it takes months to release 50 crore rupees, how can we trust you with thousands of crores? Foreign players offered technology, but refused to invest real capital, telling India, beggars can't be choosers. By 2021, India wasn't just late, it had a trust deficit. And rebuilding credibility became the first requirement. Despite these setbacks, India quietly built something extraordinary. Nearly 20% of the world's chip design engineers are Indian. Companies like Nvidia, AMD, Qualcomm, Apple, and dozens more have thousands of engineers working out of India. AMD alone employs 10,000 plus engineers here. And under the new semiconductor mission, change is accelerating. 278 universities now have access to expensive EDA tools, Cadence, Synopsys, Siemens. 67,000 students are being trained in chip design pipelines. 24 design startups have been funded under the DLI scheme. Student-designed chips have already been fabricated and packaged at SCL Mohali, a first in India. But talent wasn't the bottleneck. The real barriers were cost and market visibility. A competitive global chip can cost $250 million to design. EDA tools, compute, and tape-outs are brutally expensive. But in India, the same development could cost closer to $100 million because engineer costs are lower, global tool vendors are now offering deep discount. Equipment makers need India as a growth market after losing access to China. The second barrier was TAM, visibility into what OEMs will build 3 to 4 years ahead, which is essential for chip design. India didn't have this earlier. But with mobile and electronics assembly shifting to India through PLI, design startups finally know what India will manufacture and what chips those devices will need. For the first time, India's design startup wave has real tailwinds. Earlier attempts failed because India tried to build a fab without building everything around it. This time, the plan is different. A semiconductor ecosystem requires over 500 ultra-pure chemicals, around 50 specialty gases, equipment that constitutes 70% of the total fab cost, access to critical minerals from Africa, Australia, Canada, a supply chain with near zero downtime, precision logistics where even a one-day customs delay can halt production. India is building this entire chain simultaneously. Materials, fabs, AT&P units, design centers, equipment manufacturing, and supplier networks. Companies like ASML, Tokyo Electron, Lam Research, Applied Materials have all begun establishing a presence in India, something that never happened in previous decades. Why are they coming now? Because geopolitics has opened a rare window. US export controls cut these companies off from China, their biggest market. They lost billions in potential revenue and now urgently need a large, stable, democratic replacement market. They also fear Chinese competitors rising in EDA and equipment. So they are offering India unprecedented tool discounts, support for design startups, long-term ecosystem partnerships. For once, global geopolitics is aligned with India's ambitions. Media obsesses over 3-nanometer chips, but the real world runs on something else. 60% of global demand is at 28 nanometers and above. Automobiles typically use 45 to 90 nanometer chips. Telecom networks rely on 28 to 55 nanometers. Even Apple uses 40 to 55 nanometer chips for power management and sensors. TSMC still produces 3% of its output at 180 nanometers. India's roadmap is pragmatic. 28 nanometers to 14 nanometers to 7 nanometers to 3 nanometers. Start where the volume is. Start where India has a chance to scale quickly. Start where global demand ensures viability. Since the launch of the India Semiconductor mission in 2021, real progress has been made. 10 approved projects, 2 fabs and 8 AT&P/OSAT facilities. $18 billion, 1.5 lakh crore rupees in committed investments. Tata TSMC fab in Tolera, 50,000 wafers per month at 28, 40, 55, 110 nanometers. Micron's AT&P plant in Gujarat for advanced memory packaging. Compound semiconductor fabs in Odisha, SCL Mohali upgraded for multi-project wafer and PW runs. For the first time, India has a mix of fabs, packaging units, design pipelines, and supplier presence emerging together. This combination never existed before. A wafer is just fragile silicon. It becomes a chip only after packaging. And this is where India is surprising the world. In a Maharashtra OSAT facility, rejection rates are already lower than Taiwan. Operating margins stand at 12 to 15% compared to the global 7 to 10%. Process discipline has matched international standards. Singapore and Korea have begun routing packaging work to India. This is India's silent superpower: competitive cost, competitive quality, and competitive discipline. Vinod Dham, the father of the Pentium, rarely uses superlatives. But he calls Ashwini Vaishnaw a leader who solves problems in real time. Vaishnaw is an engineer with experience at GE, Siemens, and an MBA from Wharton, not a generalist bureaucrat. Under his leadership, Approval cycles that normally take years were completed in 100 days. States are restructuring power grids to support fabs. Customs processes have been redesigned to avoid chemical delays. Roads near fabs are being rerouted to reduce vibration. For the first time, India's semiconductor mission is being run by technocrats who understand the physics involved. To prevent the failures of the past, India created Techno-Financial Advisory Groups, TFAGs, one for fabs, one for packaging. Each proposal undergoes deep technical evaluation, financial scrutiny, multiple rounds of iteration, mandatory increases in equity, checks on technology partner credibility, elimination of debt-heavy structures. India does not allow leverage-driven fabs that collapse during downturns. Backers must have strong balance sheets and patience for 8 to 10 years of cash burn. This process did not exist in 2006 or 2015. It is the backbone of Mission 2021. A semiconductor fab is one of the most complex buildings ever constructed. A 1% fluctuation in power frequency can destroy an entire wafer batch. A truck passing nearby can cause enough vibration to halt production. Even a minor impurity in water can cause millions of dollars in damage. This is why fabs operate 24/7, consume massive amounts of water and electricity, and require clean rooms where air is thousands of times purer than a hospital's operating theater. India claims to have solved many of these challenges, but the real test is consistency. Semiconductors are a 25-year game, not a single-term achievement. In the next 5 years, India is expected to have multiple operational fabs, a complete ATMP ecosystem, advanced packaging leadership, equipment suppliers manufacturing locally, a silicon carbide and gallium nitride materials chain, a deep chip design pipeline. By 2035, global analysts expect India to become a design to fab to package nation, one of the world's most important semiconductor hubs, a major supplier for defense, telecom, power electronics, and industrial systems, a significant contributor to the global supply chain realignment away from China. This isn't optimism, it's an emerging consensus. India today stands where China stood 25 years ago, at the beginning of a long but achievable ascent. And a quiet transformation is underway. Engineers from TSMC, ASML, Micron, and Applied Materials, many who left India decades ago, now want to return. Their parents are aging. India's quality of life has improved. Serious semiconductor projects finally exist at home. For 60 years, India watched the semiconductor revolution from the outside. Today, for the first time, fabs are rising in Gujarat and Assam. Students are taping out real chips. Startups are designing their own IP. And global suppliers are landing in India to participate in the ecosystem. The world had a head start, but India has something just as powerful: scale, talent, political will, and a 25-year strategy. This is not just an industrial policy. It's the biggest technological mission in independent India's history. And the only question now is execution. Because if India succeeds, it won't just be part of the semiconductor industry. It will be one of the countries shaping it. If you want deeper insights into India's semiconductor push, its industrial strategy, and the tectonic shifts shaping the country's economic future, you need to follow Periscope. We break down India's most important transformations before they hit mainstream news: semiconductors, defense manufacturing, deep tech, AI, energy, and more. The future of India's economy is being built right now. Don't watch it from the sidelines. Follow Periscope and stay ahead.